Today we're going to spend the day reviewing factoring. And there's 5 major types of factoring. First, greatest common factor. So factoring out any numbers or variables that are common in both terms. Factoring a trinomial, a difference of two squares. So when you have two perfect squares and you're subtracting them. A perfect square trinomial, and factoring by grouping. First example is greatest common factor, and this is always the first thing that you should do. So look in this example, what number, is there a number that goes into both 4 and 10? What's the greatest number that goes into 4 and 10? Well, that's 2. Now you have an x squared and an x, so you go with the lowest of the exponents. You have an x. Now what times 2x gets me 4x squared? That's a 2x. What times 2x gets me back to 10? That's a 5. For number 2, 2 goes into both terms and so does an x. So I'm left with an 8 minus x. So you always do greatest common factor first. That's the first thing you look for. So a trinomial now. Okay, remember factoring trinomials. You want to factor an x and an x. I need two things that are going to multiply to be a 3, but add to be 4. So you look at the factors of 3. The only factors of 3 are 3 and 1. Luckily, those numbers add to be 4, so we're factored. For number 2, factor out if the x squared term is negative. Factor that out. So notice now when we have our negative. Since the 20 is negative, one of these is going to be negative, one of them is going to be positive. Now I need two things that when I multiply I'm getting negative 20, but when I add them I get negative 1. So two numbers, I think about it like this. Two numbers that are right next to each other that are going to multiply to be 20. Well, that's 4 and 5. But I need to put the 5 with the negative sign because when I add negative 5 and a positive 4, we get a negative 1. The next example. Always look for your greatest common factor. Notice how each one of these terms can be, you can factor out a 2. Now look and see. Factors of 15. 15 and 1, 3 and 5. Do any of those add to be a 9? No, because 3 plus 5 is going to be 8. So we are done with that one. Now a trinomial where a is not 1. So a in this case does not equal 1. In that other case, the a was 1. So there's a trick to these, and I call it the Mr. Hirsch method because he's the one who taught it to me. I take the 3 and I multiply it to the 5. Now I take and I factor that, like you guys are used to factoring, two things that multiply to be a positive 15, but we're going to add to be a negative or a positive 16, so that's 15 and 1. Now take, since you multiplied the 3 times the 5, we now need to divide it out. So take the 15 and the 1 and divide both of them by 3. 15 over 3 simplifies. 1 over 3 doesn't simplify, so when you have something that doesn't simplify, any denominator swings up and becomes a coefficient. So that would be 3x plus 1. You would not leave it as 1/3 there. Okay, so again, take the 4, multiply it to the negative 6. Now I need two things that are going to add to be a 5 but multiply to be a negative 24. So I look at the multiples of 24. 1 and 24. 2 and 12. 3 and 8. Now when I do, because one has to be positive and one has to be negative, so essentially when I subtract these, I need to get a positive 5, and 8 minus 3 is 5, so that's x plus 8, x minus 3. Now take and divide. You have to remember to divide. If you don't, then you're going to get it wrong. So you need to remember to divide. And that's the most common mistake that students make, is they forget to divide. So this is going to be x plus 2. The 4 can swing up and become a coefficient. And we're good. So again, remember to divide out whatever you multiplied in. Difference of two squares. Please make sure you write this down. So if you have essentially what it sounds like, difference of two squares. Perfect square minus a perfect square. It's going to be a minus b times a plus b. Because when you multiply the middle terms, those middle terms have opposite signs, so the middle term goes away. So what I'm going to do is we're going to do x, since x squared minus 49, that's difference of two squares, x minus 7, x plus 7. For number 2, this is like saying 5x squared minus 8 squared. So we have 5x minus 8 and 5x plus 8. Always remember your greatest common factor. Notice that 2 and 50. I could factor out a 2. Now I can factor this even more to be x minus 5y and x plus 5y. Now if it's a sum of two squares, this is a plus sign in the middle, we can't factor. When we can't factor, we call that prime. Now, perfect square trinomials. This happens when your first term's a perfect square, the second term's a perfect square, and the middle term is twice the product of the square roots of those. So for this first one, the first term's a perfect square. The last term's a perfect square. Is our middle term 2 times 5 times x? It is, so it's our perfect square trinomial. Number 2. First term's a perfect square. Last term's a perfect square. Is our middle term 2 times 3 times 7x? Well, 3 times 7 is 21, times 2 is 42. So this works out to be 3x, take the same sign, minus 7 squared. Next one. We have what appears to be, again, 2x squared, 9y squared. Now, is our middle term 2 times by the 2x times by the 9y? Well, 4 times 9, that's 36, so that works out. So this one's going to factor to 2x minus 9y squared. Okay, grouping. Think of this as one term, and this is one term. Grouping is a fancy way of doing greatest common factor. What's common in both those terms? Both those terms have an a minus 3. So that can get pulled out in front. Now what's left over? If I factor out the a minus 3, we're going to have a 5 minus 2a, because the a minus 3 got factored out. So that's the simple grouping. A more complex grouping. It's called grouping because you group the first two terms together and factor out the greatest common factor. So what's common in both those? X squared. What am I left with? X minus 3. Second two terms. You have to carry this minus sign with it. So I'm going to factor out a negative. What's common in both those? 4. Now what am I left with? X minus 3. Because if I were to distribute that negative 4 back in, that would make it a positive. Okay, so what's common in both those terms? X minus 3. And then what am I left over with? I'm left over with x squared minus 4. Now be careful. You're not done yet, because x squared minus 4 can still be factored. That's a difference of two squares. Okay, next. Group your first two terms together. 4x squared. What am I left with? X plus 2. You need to factor out a negative 9. This sign stays with it so that you have an x plus 2. Now what's common? X plus 2 is in both terms. What's left over? 4x squared minus 9. So now try and factor even more. We have x plus 2, 4x squared minus 9, well that's 2x minus 3, and 2x plus 3, because that was a difference of two squares. Okay, there are your lesson questions, and please make sure you submit those on time.